system. Right now, somewhere past the edge of our solar system, a spacecraft built in 1977, older than most laptops, older than the internet, is slowly dying. NASA engineers are racing to save it, with a plan they literally call the Big Bang. If it fails, we lose contact with the most distant object humanity has ever built. On September 5, 1977, at 12:56 UTC, a Titan Centaur rocket lifted off from Cape Canaveral's Launch Complex 41. On board, Voyager 1, carrying 11 scientific instruments and 3 nuclear generators producing about 158 watts each. It launched 2 weeks after its twin, Voyager 2, but on a faster trajectory. By December 15th, just 3 months later, Voyager 1 had already overtaken its sister ship. In March 1979, it swept past Jupiter, just 280,000 kilometers away. It found a faint ring system no one knew existed. It discovered 2 new moons. The atmosphere below was more turbulent than anyone expected. The next year, at Saturn, it found 5 new moons, a new ring, and shepherd moons, tiny satellites that hold Saturn's rings in place with their gravity. It looked closely at Titan and found something extraordinary: an atmosphere that was 90% nitrogen, laced with methane and complex hydrocarbons, the kind of chemistry that could, in theory, lead to life. Then, on February 14, 1990, from 6 billion kilometers away, beyond the orbit of Neptune, Voyager 1 turned its camera around. It took one last photograph of everything it had left behind. 6 planets, including a tiny, barely visible speck of light. Carl Sagan, sitting in a press conference watching that image, said this: "This is where we live, on a blue dot. That's where everyone you know, and everyone you have heard of, and every human being who ever lived out their life. It's a very small stage in a great cosmic arena." It was the last of 67,000 images Voyager would ever take. Crossing into the unknown. After that photo, the mission changed. Voyager 1 was no longer a planetary explorer. It was heading somewhere no human-made object had ever gone: interstellar space. Nobody knew how far that boundary actually was. Voyager's own project scientist, Ed Stone, admitted it on camera. The boundary of this bubble may be 100 times as far as the distance from the Earth to the Sun. No one knows. It took until August 25, 2012, 35 years after launch, for Voyager 1 to finally cross that boundary, the heliopause, at 18 billion kilometers from the Sun. It became the first human-made object to ever leave the bubble our Sun creates around our solar system. The Big Bang. So now, engineers are working on something bigger. A coordinated plan nicknamed the Big Bang, swapping out several power-hungry systems at once for lower-power alternatives, all in one risky move. They're testing it first on Voyager 2, which has slightly more power to spare. If it works, they'll attempt it on Voyager 1 no earlier than July 2026. If it succeeds, there's even a chance the instrument they just shut down could come back online. If it fails, they lose a year of margin they can't get back. The slow goodbye. But survival out here comes at a cost. Voyager runs on plutonium, heat from radioactive decay converted into electricity. And every single year, without exception, it loses about 4 watts of power. Forever. There's no fixing that. So one by one, NASA has had to turn off Voyager's senses. Its cameras, the ones that captured Jupiter's storms, Saturn's rings, the pale blue dot, went dark in 1990, the same year as that final photograph. Its ability to directly taste the solar wind, gone in 2007. Of the 11 original instruments, only 2 are still active today. One that listens to magnetic fields, and one that listens to plasma waves. The most recent cut happened on April 17, 2026. During a routine maneuver in February, Voyager 1's power dropped unexpectedly, enough to risk triggering an automatic shutdown that could have put the entire spacecraft at risk. So the team made a hard call. Shut down the low-energy charged particles instrument, one of the last 2 still gathering unique science. Just sending that single command took 23 hours to reach the spacecraft. The shutdown itself took another 3 hours and 15 minutes. And this one move, turning off one instrument, only buys Voyager about 1 more year. They didn't shut it off completely, though. A tiny motor inside it, using less than half a watt, keeps spinning, just in case they ever find enough power to turn it back on. While shutting down a science instrument is not anybody's preference, said Mission Manager Kareem Badarudin, it is the best option available. One light day. On November 18th, 2026, at 2:16 a.m., Voyager 1 will cross a distance NASA calls a milestone like no other. 1 light day from Earth. 16 billion miles. The distance light itself takes a full 24. Good morning, Voyager. She won't hear the reply until Wednesday morning. 2 days. Just to say hello. A letter that will outlive us all. But Voyager isn't just a machine slowly running out of power. Bolted to its side is something else entirely. A golden record. Its cover is covered in symbols that look almost alien themselves, but every single one was placed there with one purpose: to be understood by someone who has never seen a human, never heard a single human word, and might not find this message for 1 billion years. In one corner, instructions on how to even play the record, using the only truly universal unit of time scientists could find, the transition period of a hydrogen atom. In another, a map, not of Earth, but of our position in the galaxy, marked by the precise rhythm of 14 pulsars, cosmic lighthouses that don't change, even over millions of years. And embedded right into the cover, a tiny sample of uranium-238. It decays at a perfectly known rate, a half-life of 4.468 billion years. Whoever finds this, in 1,000 years or 1 billion, can measure exactly how much has decayed, and know precisely when this message was sent. Inside, 115 images of life on Earth. The sounds of surf, wind, thunder, birds, whales calling to each other. 90 minutes of music. Mozart, Bach, Chuck Berry, Blind Willie Johnson. Spoken greetings in 55 languages, starting with Akkadian, spoken 6,000 years ago in Sumer, and ending with a modern Chinese dialect. Each record was hand-cut, then gold-plated on August 23, 1977, by real people who knew they might be making something that outlives the human species itself. And on its surface they hand-engraved one simple inscription: to the makers of music, all worlds, all times. Carl Sagan, who helped create this message, was honest about the odds. The spacecraft will be encountered and the record played only if there are advanced, spacefaring civilizations in interstellar space. It will take 40,000 years before Voyager 1 even comes close to another star system. 40,000 years. Longer than all of recorded human history, several times over. But as Sagan put it, the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. The engineers who built Voyager have retired. Some have passed away, The Cold War that drove its launch ended decades ago. Schools where kids first learned about this mission have been torn down. And Voyager 1 is still out there, still listening, still trying. It will keep losing power, year after year, until sometime in the early 2030s, when even its last instrument goes silent. After that, it won't stop. It will keep traveling outward at 38,000 miles an hour for an unbounded stretch of time, carrying its golden message into a darkness with no shore. We may never know if anyone ever finds it, but we sent it anyway.